Today we are going to learn about mastering Python class inheritance best practices. You will gain the skills to effectively use inheritance for creating efficient, reusable Python code. Welcome to our tutorial on mastering Python class inheritance best practices. Inheritance is a fundamental concept in object-oriented programming, OOP, that allows us to create a new class based on an existing class. This not only promotes code reuse but also helps in building scalable and maintainable applications. Understanding inheritance is crucial because it serves as the foundation for designing efficient class architectures. Throughout this video, we will explore the principles behind inheritance, how to implement it effectively, and the best practices for optimizing your Python projects. Inheritance offers numerous advantages in object-oriented programming. Firstly, it promotes code reusability by allowing you to use existing code as the foundation for new classes, reducing redundancy. This aligns with the don't repeat yourself principle, which is a cornerstone of efficient coding practices. Moreover, inheritance simplifies code maintenance since changes in the base class automatically propagate to derived classes, ensuring consistency across the application. Additionally, it enhances code readability by establishing clear hierarchies and relationships between classes, making it easier to understand the architecture. Finally, inheritance facilitates scalability by allowing you to extend and modify functionality without altering existing code. To effectively use inheritance, it's essential to understand how to create a base class and extend it with derived classes. A base class, also known as a parent class, serves as a blueprint for other classes. In Python, you define a base class using the class keyword, followed by the class name. Derived classes, or child classes, inherit attributes and methods from the base class, allowing for the extension and customization of functionality. Establishing clear class hierarchies is crucial for maintaining a structured codebase. In practice, consider a vehicle base class with derived classes like car and bike, each extending the base class with specific attributes and methods. Best practices for class creation include using descriptive names, minimizing dependencies, and ensuring that each class has a single responsibility.
Method overriding is a powerful feature of inheritance that allows a derived class to provide a specific implementation for a method already defined in its base class. This is particularly useful when you need to modify or enhance the behavior of inherited methods. To override a method, simply define a method in the derived class with the same name and signature as the one in the base class. However, it's important to adhere to best practices, such as maintaining consistent method signatures and ensuring that the overriding method's functionality aligns with the base class's intent. A common error to avoid is unintentionally overriding methods due to typos or mismatched signatures, which can lead to unexpected behavior. By carefully implementing method overriding, you can tailor class functionality to meet specific requirements while preserving the integrity of the original class design. The superfunction in Python plays a crucial role in inheritance by providing a way to call methods from a parent class within a derived class. This is particularly useful in complex inheritance scenarios where multiple classes are involved. By using super comma, you can avoid redundant code and ensure that the parent class's methods are invoked correctly. For example, when overriding a method in a derived class, you can use super to call the original method in the base class, allowing for additional logic to be executed before or after the base class's implementation. This not only improves code maintainability but also ensures that the overall class architecture remains consistent. However, it's important to use super judiciously and understand the method resolution order, MRO, to avoid unexpected behavior in cases of multiple inheritance.
While inheritance offers many benefits, it's important to be aware of common pitfalls that can arise if not implemented correctly. One major issue is circular dependencies, where classes are interdependent in a way that creates a loop, leading to potential runtime errors. It's crucial to design class hierarchies carefully to avoid such situations. Additionally, managing complex hierarchies can become challenging, especially when multiple levels of inheritance are involved. To mitigate this, adhere to the single responsibility principle, ensuring that each class has a distinct purpose and scope. Clear and comprehensive documentation is also essential to keep track of class relationships and dependencies. By proactively addressing these pitfalls, you can maintain a robust and reliable codebase, leveraging the full potential of inheritance without encountering unintended side effects.
Adhering to best practices for class design and code readability is paramount in developing maintainable and scalable applications. Start by applying principles of effective class design, such as encapsulation and modularity, to ensure that each class has a clear and focused purpose. Enhancing code readability involves using descriptive names for classes, methods, and attributes, making it easier for others to understand the code's intent. Consistent styling, such as following PEP 8 guidelines, contributes to a uniform codebase that is easier to navigate. Moreover, incorporating comments and comprehensive documentation is vital for explaining complex logic and class interactions. By prioritizing these best practices, you can create a code structure that is not only functional but also intuitive and accessible to collaborators.
To truly grasp the power of inheritance, let's explore some real-world applications where inheritance plays a vital role. Consider an e-commerce system that employs inheritance to manage different product categories. A base class product can be extended into electronics, clothing, and books, each with specific attributes and methods tailored to their category. This structure not only simplifies inventory management but also facilitates the addition of new categories with minimal changes to the existing codebase. Another example is an educational platform where a base class user is extended into student and instructor, each with unique permissions and access levels. By leveraging inheritance, the platform can efficiently manage user roles and permissions, ensuring a seamless experience for both students and instructors. Insights from industry experts underscore the importance of using inheritance judiciously, balancing class hierarchies with the need for flexibility and scalability. As we conclude our exploration of mastering Python class inheritance best practices, let's recap the key concepts we've covered. Inheritance is a powerful tool in OOP that promotes code reusability, simplifies maintenance, and enhances scalability. By understanding how to create base and derived classes, override methods, and use the super function, you can optimize your Python projects effectively. It's important to apply best practices, such as maintaining clear class hierarchies and adhering to the single responsibility principle, to avoid common pitfalls. Ultimately, inheritance empowers you to build scalable and maintainable applications with a clean code architecture. We hope this tutorial has equipped you with the skills to leverage inheritance in your Python projects. Thank you for joining us.